Welcome again, everyone, to STEM Lab's Competition Mathematics series. We are still talking about algebraic manipulation, and this is part 4. And this time, we will be looking at a few past PMO questions. So here are the questions that we will be discussing. Um, so why don't you pause the video here for a little bit and try and answer these questions? And when you're ready, come back and we'll talk about the solutions. Okay, if you're ready, here we go. This question is from the 2018 qualifying round. We're given if the difference between two numbers is a and the difference between their squares is b, with a and b both positive, what is the sum of their squares? Okay, let us consider our numbers to be x and y. We have the following given information. Say x minus y is equal to a, and the difference between their squares, x squared minus y squared, is equal to b. Using special products, we notice right away that x squared minus y squared may be written as x plus y times x minus y, and this is equal to b. Hence, we can say x plus y times a is equal to b, and therefore x plus y equals b over a. Now we're looking for the sum of their squares. So we're looking for x squared plus y squared. So if you recall, we've done this technique before to make x squared plus y squared appear. We could square either x plus y or x minus y. Okay, so let's do that. So again, we have x plus y equals b over a. And if we square this, that gives us x squared plus 2xy plus y squared equals b squared over a squared. So we have the x squared plus y squared that we want, but we have this 2xy in the middle that we need to get rid of. Now remember, we also know that x minus y equals 8. And if we square this, we get x squared minus 2xy plus y squared is equal to a squared. So now we have these two equations. We have the middle term 2xy in both of equations, but they are of opposite signs. So this is very useful for us. What we can do is simply add the two equations. And notice on the left side, when we add them, the middle terms will cancel out. And we're left with 2x squared plus 2y squared. Meanwhile, on the right side, we're left with b squared over a squared plus a squared. So this expression on the right side now, we can combine this into one fraction by multiplying the second term by a squared. That will give us b squared plus a raised to 4 all over a squared is equal to, on the left, we can write this as 2 times x squared plus y squared. Again, we're looking for x squared plus y squared, so all that's left to do is divide this by 2, and when we divide by 2, we get b squared plus a raised to 4 over 2a squared. That is the required expression. Moving on, this question is from the 2019 qualifying. It's question number 2, so it's actually quite easy. We've done something similar to this before. So we're given x minus y equals 4 and x squared plus y squared equals 5. We're looking for x cubed minus y cubed. Okay, so this expression that we're trying to evaluate, that is a difference of cubes, and we know that this factors into x minus y times x squared plus xy plus y squared. Okay, so we already have a lot of stuff that we need here. X minus y is already given, and in the second factor, we know x squared plus y squared. So the only thing that we still don't know is xy. To find xy, we'll take a quick detour here. From the first equation, x minus y equals 4. Remember, we can make xy appear by simply squaring this expression. So if we square the first given equation, we get x squared minus 2xy plus y squared equals 16. And in this expression, we have the terms x squared plus y squared, which we know is 5. So we can write this now as 5 minus 2xy equals 16. So it's now just a matter of moving things around. We get 5 minus 16 equals 2xy. And that gives us 2xy equal to negative 11, which means xy equals negative 11 over 2. And now we have all the values that we need. So going back, x cubed minus y cubed equals x minus y, which is 4. And the trinomial factor, we have x squared plus y squared is 5, plus xy, which is negative 11 over 2, so that becomes minus 11 over 2. So it's just a matter now of evaluating this. That's 4 times 5 minus 11 over 2 is negative 1 half. And 4 times negative 1 half finally is negative 2. And that is the value we're looking for. Okay, moving on. The following question is from the 2018 areas. And we're given, suppose that x and y are non-zero real numbers such that The quantity x plus 1 over y times the quantity y plus 1 over x is equal to 7. Find the value of the quantity x squared plus 1 over y squared times the quantity y squared plus 1 over x squared. So we begin by looking at this expression that we're given, x plus 1 over y times y plus 1 over x equals 7. And what we're going to do is we're going to expand the left side. We're going to do the multiplication. So we get x times y plus x times 1 over x, which is 1, plus 1 over y times y, which is also 1, plus 1 over y times 1 over x, which is 1 over xy. This is equal to 7. Now moving the two ones from the left to the right side, we get xy plus 1 over xy equals 7 minus 1, which is 5. Alright, meanwhile, let's look at the expression that we're trying to evaluate here. We're looking for x squared plus 1 over y squared times y squared plus 1 over x squared. And we're going to look for some insight by expanding this multiplication. It's going to be x squared y squared plus 1 plus 1 plus 1 over x squared y squared. So now we notice some relationships here. In this expression that we got as a result of manipulating the given equation, notice that the terms on the left side are similar to the terms on the expression we're looking for, except the terms here are squares. So once again, that gives us a clue. Let us try squaring this expression. And notice that when we square this, we get x squared y squared plus the middle term is 2 times xy times 1 over xy. And xy times 1 over xy is 1. So the middle term here is 2 plus the square of the second term, 1 over x squared y squared, which is equal to the square of the right side, which is 25. And the stroke of insight here is to notice that the result we got from manipulating the required expression and the square we got here are in fact exactly the same. Hence, the value we're looking for is already here. It's equal to 25.